Okay, we're back. MCT4C, Day 10, Lesson 2.0 on function review. We were just talking about vertical line test and functions versus non-functions. Domain and range. We talked a little about domain and range already. Um, we said the domain are kind of like the inputs, and in fact, that's what it is. It's the set of all inputs. So it is the set of all inputs possible. And sometimes, as we'll see in the examples below, that there's a restriction on the input and not all of them are allowed, right? And we think of this as along the x-axis. So all the possible values along the x-axis. And the range is the set of outputs. And we think of, the outputs being what do we get after all the inputs are substituted into a function or whatever. But often when we're talking about domain and range, we're thinking about a graph, and that's what we've got below here. This is a great sort of picture of how to think of domain and range when you're given a graph. So we think of there's like a squiggle function. We don't know what the equation of this is. We don't know what the numbers or anything like that is. But the domain is kind of like if you had a flashlight, it's the shadow on the x-axis. We see, so over here there's no function to cause a shadow on the x-axis, so these values of x over here aren't part of the domain, right? And so these values, whatever they happen to be on the x-axis, are the domain. These are the set of all inputs possible, right? And similarly, the range is the shadow on the y-axis, on the vertical axis. So, it goes as low as this spot right here, and then all of this stuff has shadow on it, some of them from both sides to here. So I'd have to describe the range as this set of numbers right there. Okay, and we're going to practice writing these as sets of numbers and picking out the domain and range in a second. So example 1, given each graph, state whether it is a function or not, and then the domain and range. No problem. Review of grade 11. Here's my vertical line. And is this a function? Well, it's not a function if it crosses the graph in more than one spot, right? That's the vertical line test. It passes, doesn't it? So this one's a function. Well, what's the domain? The domain is the shadow on the x-axis. So what are the x-axis values that would have shadow on? Well, I can see all this would be in shadow, and all this would be in shadow. The cutoff spot's right here, right? So that's where the shadow would start. And then if I go this way, I'm getting shadow up from this direction, and the cutoff's here. I can see where the cutoff is, and in between those two is all domain. Right? That's the domain. And so if I want to write it, I'm going to D for domain. We write it in set notation. And then how do I describe this set of numbers? Well, I could say in words, the domain is all numbers from -2 to 7 inclusive, or including -2 and 7. But, that's a lot of words. We like to be short. And in math, we do it in symbols. So we say -2 is less than or equal to x, which is less than or equal to 7. And the way I remembered it in the curly brackets to show it, it's a set. The lowest is on the left. We always read from left to right. -2 to 7 are kind of like the goalposts, and x is in between them. The symbols, when we're describing a set of numbers like this, are always less than. So -2 is less than x is less than 7. And I know some students have trouble reading these symbols. They get mixed up whether that's less than or greater than. And everyone remembers that, that it's like a Pac-Man or a fish or something that's going to always go towards the bigger one, but that doesn't help you read that, right? Especially when we've got x's involved. The way I remember it, that one is the one that kind of makes an L. That looks like L for less than. That one kind of makes a G for greater than. And so whenever you see that, you know that's a less than, okay? Anyway, a little aside there. Now let's do the range. Different color. Maybe green. Sure, green. And so the range is all the shadow values on the y-axis, and I can see, well, yeah, there's some in here. How far down does it go? Well, it goes to right there, right? Right there is how low it goes, all the way, even here, but keeps going this way, right? I'm getting shadow values from over here. All of this from -1 up to 6 is the range. This is the range, isn't it? So I write from -1 is the lowest, is y, because range is y values, all the way up to 5. It looks like. That's the domain and range. All right, let's pick up the pace here. The next one makes sense that if this one's a function, probably I'm going to have an example of not a function, right? And I can see right there, right away, this crazy function. There's the equation for it. It's crazy. Cuts the graph in 2 spots. So not a function. Fails the not a function because it fails the vertical line test. But I can still talk about its domain and range, can't I? So the domain is all the values shadow on the x-axis. I can see they start here. There's no x values over here. And that's all shadowed in, shadowed in, shadowed in, all the way from there to there. From -5 to 5. And so I'm going to write that down. Oh, hang on. That was part A. This is part B. Domain is -5 is less than or equal to x is less than or equal to 5. And then the range, well, I can see there's shadow here all the way up. It's probably supposed to go all the way up to 2, but it's pretty close. 2 and -2, right? That's the range. So from -2, I always start the lowest one, is less than or equal to y is less than or equal to 2. Dandy. That's it. Is there anything else down here? Oh, there is. It says look at graph 1 and example 1. So that's this one, which kind of looks like a problem. It says state f at 3. Well, what does that mean? Well, f at whatever is an output value. So it's asking for an output value when the input is 3. An input of 3, what's the output? An input of 3, there's the input of 3 right there. What's the output? Well, I go bounce off the graph. It's -1, isn't it? So I'd write input of 3, output of -1. That's all I have to do. B is kind of weird. Use different color again. It's asking for an x value. So we want to find the input value so that the output value is 1. My graph is getting kind of full here, but an input value, I don't know the input, I don't know where to go on the input value, but I know the output value is 1. Well, there's 1 right there, right? And I can see an input of 0 gives me an output of 1, right? So I could say f at 0 equals 1. So one of my answers is x equals 1. But did you notice this? Over here, anything along this, right there, that has an output of 1, a y value of 1. So there's a second answer, right? So also, f at 6 equals 1. X equals 6. Saying, well, hang on. I thought this 2 value thing wasn't allowed. Well, it's not. This is okay because it's got one output value for 2 different input values, right? It's that I'm not allowed to put one input and get 2 outputs. In part B, an input of 2 gives me an output there and an output there. One input gives me 2 outputs. One input gives me 2 outputs. In this case, one input gives me 1 output, but if I'm thinking about the outputs, I am allowed to have 2 different input values that gives me the same output value. So this is okay. Don't get too worried about that. That must be it there. Last example. If we were given the equation of a function, finding the domain and range are a lot more difficult. And that's true. So there's an equation. What's the domain and what's the range? Well, who knows? Can't see it. There's no shadows, nothing like that. So, of course, the first thing is we could graph it. Say, well, I don't know how to graph that. And that'll happen this year and in your math career, that you'll be asked to find domain and range of stuff that you don't know what the graph looks like. So, what do? Well, you could use a table, try some values of x, figure out what y is, and then graph it. But that's slow. So I'm going to put a sad face there. Better is use a graphing calculator or some form of technology. Use a graphing calculator. And then have a look at it, right? Is it cheating to do that? No. Probably some of you might have an app on your calculator that, or you could download it for 0 cents. That would do that. And then it's easy to get the domain and range once you have a function, once you have a graph, rather. Another thing is, and this is what we're going to do first, and we'll go backwards and look at the graph later, is we can think about restrictions. And I'll tell you what I mean here. Unless it says so, x, we're going to let x be anything it possibly can. But we see that we're taking the square root, right? The square root of something, that's, we can't take the square root of a negative, right? So whatever we decide that the domain and range are, we know that this number underneath the root sign, that thing there can't be negative. Well, what values of x would make the cutoff? Notice if x is 4, it's fine, because 4 subtract 3, that's, even if x is 3, 3 subtract 3 is 0, the square root of 0 is 0, and that's fine. So, in fact, anything less than 3, that's bad. So if x is 2, 2 subtract 3 is -1, the square root of -1 is bad, right? That one we don't know, so we can't do that. So the domain, restricted values, is x has to be greater than or equal to 3. Otherwise, we're going to take the square root of negative and we get a sad face. So that should be the domain if we're just thinking, not thinking about restricted values. Well, what about the range then, if we think about this? Well, think about what types of values are square roots. Like, what types of values are coming out of this? Well, they're never going to be negative, right? They might be 0, and in fact, and we said if x is 3, 3 subtract 3 squared is 0, 0. So this is going to be 0 or more, isn't it? And I can think of the outputs as y is greater than or equal to 0. Now, sometimes this second way is really hard, and probably, I'm hoping that most of you followed my logic there, that it made sense. But certainly there's going to be TI-83s available for us. I'm going to see if I can find my TI-83, get her going and show you. Where's my math programs? Here's my math programs. Right there, TI-83. It'll take a second to fire up. I'm going to run that. There should be some lane in the around the classroom for you. All right, so there's some sort of log graph already in there, but I'm going to clear it off, and then I'm going to put in the square root in brackets of x minus 3, and then I'm going to put zoom standard, say. So I think standard goes from -10 to 10. And we see, let's see, what are the x values that will have shadow? Well, it's there and everything higher. X has got to be greater than 3. Well, what about the y values? What y values will I have shadow on? Well, it's going to be there and then everything higher. Notice that this is going to keep going forever, right? So y is greater than 0. So there's the graph. I'm going to maybe include that. Geez, that looks so nice. Take a screenshot of that. Put that in my note because it's so nice. There. There's the check. I'd probably expect you to do the technology first. Of course, this is math for technology. Use the technology. Okay, folks? Well, that's it.